Hi, today we're going to build this mic mixer with particular emphasis on the mute and solo buttons. I'll just make that a little bigger so we can see it more fully. I already made a video last year showing one method of handling mute and solo buttons. Shortly after I posted that video, Lindon from Channel Robot sent me a message and told me he had another way to do it. And in my opinion, it's a better way. So that's what we're going to look at today. This is the method that Lindon showed me. In my original version, the volume control and mute and solo buttons were all linked together. In this new version, it behaves a bit more like the mixer controls in a DAW. The controls on the front end are more separate from each other. Both the mute and solo button can be enabled at once, which is different to my previous version. And the solo button takes precedence over the mute button. So we'll make a new project and we'll begin by adding 3 simple gain modules. These act as the mic channels for our mixer. We'll just name those 0, 1 and 2. Next we'll add an interface script and begin constructing the GUI. And these will have the mode set to decibel. And we'll also need 6 buttons, the mute and solo for each channel. We won't be using the processor and parameter ID to connect these knobs to the simple gain modules. We'll be doing it all through scripting. And the first thing to do in our main interface script is to defer all callbacks. This is just a kind of standard thing you should do unless there is some reason you need to be running things in the real-time thread from your main interface script. Next, we'll declare a constant that we can use throughout the rest of the script that defines the number of channels that we have. So if you're making a script with more channels than this, you'd obviously just change that number to however many channels you have. And then we need an array to keep track of which solo buttons are pressed. We're going to call this solo state. Now we need to gather all our GUI components together. Because each channel has the same number of components, a gain knob and 2 buttons, we will just use one loop to get all of the components and we will store them in separate arrays. And we'll also use the same loop to get a reference to each of our simple gain effects. And we'll store those in an array as well. So we'll declare the loop now. So it's going to go from 0 to the number of channels. And I made sure all of the components and the modules have loop-friendly names. By that I mean all components that do the same job have the same name followed by a number that we can reference as we go through our loops. The mute buttons are all called btn mute followed by = either 0, 1 or 2 for example, depending on which channel they will control. So first we'll get the gain effects. And because we're in a loop and we need the number of the channel 0, 1 or 2, we can use our iterator I and just add it to the end of the string like that. So first time through the loop that will be simple gain 0, the second time will be simple gain 1, and the third time will be simple gain 2. And we'll just do the same for the mute and the solo buttons. Now we have all of our components, we need to assign control callbacks to them, and we can do this in the same loop. So we'll just add a bit of space for each one. And we'll declare the callback functions in a moment, but all of the gain knobs will share a callback function, all of the mute buttons will share one, and all of the solo buttons will share one. And what I've realized is that I've accidentally called these mute and solo buttons KNB instead of BTN. So let's just change that. You've probably noticed that already. So that should be BTN. That's why you shouldn't copy and paste your code, because you'll make mistakes like that. So the next thing we've got to do is just write all of our control callback functions. We'll start with the simplest one, which is the mute button. All we're going to do in the mute button's callback is call a function called solo mute process. That's it. That's the mute button's callback done. We'll write this function in a little while. On to the solo buttons. First, we will find out which of our solo buttons trigger the callback. To do this, we're going to use the handy indexOf function that you've seen me use a bunch of times before. And that will set index to 0, 1 or 2 depending on which of the mute buttons was pressed. Now that we have the index of the button, we need to make use of our solo state array that we declared earlier, this array here. We're simply going to record the value of the solo button, which will either be 0 or 1. This means that later we can use the solo state array to quickly find out which solo buttons are enabled without having to check each one manually. The last thing we're going to do in this callback is call the solo mute process function, which we're still going to declare later, just like we did in the mute button callback. So we're going to call this function here as well. And now it's time to write the gain knob callback. We'll actually do that above these two, and the reason for that is because that's the order they appear in the interface and in the component list, so by putting the callbacks in the same order it makes it a little bit easier to navigate through the code. So we'll get the index for the gain knob that triggered the callback using the same technique we used for the solo buttons. Then we need to apply the value of the gain knob to the simple gain module for whichever index we've got here. So if this gives us index 0, the first knob, we'll apply the gain value to the first simple gain modulator. Now before we can apply the value to the simple gain, we need to perform a check. We only want to change the simple gain if certain conditions are met. Firstly, the channel must not be muted, because if it's muted, we always want its gain to be 0. Then we need to check that no other channels are soloed, because if another channel is soloed, let's say channel 1 is soloed, then the gain of this channel, channel 0, must be 0. And finally, we need to check if this channel is soloed, so if this one's soloed, in which case we allow the gain to be changed, and this is okay even if another channel is soloed, because we can have two channels soloed at the same time. We can do all of this in a single if statement. So first, we'll check if the channel is not muted by checking if the value of its mute button is 0. So we're going to check, for example, for gain 0, we'll check if the mute button's value is 0. So we do that, and we use the index of the gain knob to make sure it's the same channel, and we write .getValue is 0. So we're checking, we're saying, is the mute button of whichever channel, is it 0? And we can write this in a slightly shorter form. We can get rid of that and just put an exclamation mark at the beginning, and that does the same thing. So that's using the not operator. Then we check if there are no solo buttons active. We do this using our solo state array. All we need to do is check if the array contains a 1, because if it does, that means at least one solo button is active. And we can use the contains function to do that. So that's why we were storing the value of all the solo buttons in the solo state array. So we'll say and not solo state dot contains 1. So we're saying the channel, if the channel is not muted and there are no solo buttons active, and the last check we need is to check if the solo button for the current channel, whichever channel index is active, because if it is, then in that case we do allow this to move. And to do that, we're going to use an OR, which is written like that, 2 pipes, and we do that by checking the solo button array, and doing it this way also gives precedence to the solo button over the mute button. Now, one last thing we need to do to this if line is we have to make sure that this is treated as one clause. So checking the mute button and checking all the other solo buttons is one clause, and this last bit is a separate clause. So to add a bit of separation to these, we're just going to put them in parentheses so that they become 2 separate groups. So now this is one thing, and if it's that or this other thing, then we will continue through the if statement. And now that we've done all that checking, and we've confirmed that we are allowed to apply this gain to the simple gain module, we can now go ahead and apply the gain to the simple gain module. So gain effects, and we use that index so that we're setting the correct simple gain, and it's going to be .set attribute with 2 T's, and then it's gain fx index dot gain. So what we're using here is a constant that is part of the simple gain module, and to find out these constants you can look in the module browser. If you don't have this module browser, then you hit F6 and you can add a module browser if you have space for one. You have to click the plus button up here, right click in here, and then then you press F6 again once you've got the empty panel, then right click and select module browser, and then you'll have a module browser there. So I'll get rid of that one. So in the module browser, we can go down and look for the simple gain effect, which is in here. And if we right click on it, we can see the various parameters that are available to us. These are the constants, and the one we're going to use is gain. So we've got that here, and we need to apply the value of the knob, and we set the knobs to decibel mode, so they're already going to be in the correct format, and we're just going to put value in there and hit F5. We've got some errors there. I'm just going to clear the console. We won't worry about the errors for now. We'll fix any errors later on. The last piece of the puzzle is the as yet unwritten solo mute process function. This handles the actual muting and soloing effect. So I'll write this down here. In this function, we're going to have a loop that checks the current state of each channel's mute and solo buttons and applies the appropriate adjustment to the simple gain modules. The muting and soloing effect is created by setting the gain of the simple gain modules to 0 for any channels that are muted, or any channels that are not soloed if another channel is soloed. So for example, if channel 2 is soloed but channel 1 isn't, then this one will be muted. Although we won't see it on the interface, we'll only see it on the simple gain modulator. The interface will stay the same to preserve the previous volume setting. We'll do this with an if statement that performs two checks. The first part checks if there are no active solo buttons. We'll use the same technique we used in the gain knob callback, checking if the solo state array contains a 1 to indicate that a solo button is active. Then, using the OR operator, we can check if this particular channel is soloed. The second part checks if this channel is not muted or this channel is soloed. So two parts of it are going to be checking if this channel is soloed, and because this is happening in a loop, it's actually going to be checking every single channel. So we're going to check all the channels in one go and apply the appropriate action to the simple gain modules. So let's write this function. So we'll have our loop. That checks every single channel. So we'll have our if statement inside the loop. So it is important to remember this is inside the loop. So everything we're doing here is going to apply to all of the channels. And I'm putting this first part in parentheses inside the if statement to separate it, just like we did for the gain knob callback. So we're checking if a solo button is pressed. Another way you could do this, by the way, just so it's a bit clearer to see perhaps if you were doing this longhand, I'll just write it here, is you could do your if statement like this. If btn solo 0.getValue or btn solo 1.getValue, etc. And you'd do that for each solo button. So if you had 10 solo buttons, you'd have to write out each one. Which is why I prefer this method of using the solo state array, because we just use the contains function on the array, and this will handle an arbitrary number of solo buttons. So that's checking if any solo buttons are enabled, and now we're going to check if this particular solo button is enabled. And by this solo button, I mean whichever one we're currently iterating, so we're going to use I as the index there. And then the second part of this if statement, we're going to go off the screen a bit here. So let's make this, let's hide the component list and give ourselves a bit more room. So the second part, we're going to have an and again we'll put this in its own set of parentheses to separate it into a separate clause. So we're checking if it's not muted, or it is soloed. So it's not muted or it is soloed. And if these conditions are met, that means the channel does not have to be set to 0. Ignore those errors, we'll fix those later. But yes, if these conditions are met, it means this channel, so whichever channel's being iterated, does not have to be set to 0 because it's not muted and other channels aren't soloed without this channel being soloed, etc. So what we do is we set the simple gain module to match the knob's value. And remember, this function's only being called from the buttons, so this isn't affected when you move the knob, it's only when you click the buttons. And to set the simple gain, we're going to use pretty much what we use for the knob callback, gain effects, i.set attribute gain effect i.gain, and then we want to set it to the gain knobs value. Okay, and then if none of these conditions are true, so either the channel's muted or another channel soloed and this one isn't soloed, then we're going to set the gain effect to minus 100, which is the equivalent of muted. So we'll have else, and we'll just copy and paste that in there. And for the value, we'll just put minus 100. And we'll hit F5 on that. It's compiled okay, no errors so far. This bit of code might take a moment to get your head round, so if no channels are soloed, or the one we're currently iterating with our I variable is soloed, and the channel isn't muted, or it's muted and soloed, so solo takes precedence, then we set the volume to the knobs value, otherwise we mute it. So now I will zoom in on this bit of code and hide the interface so you can see it in full, and just give you a moment to contemplate the logic that is happening here. So that's it, we're done, except we have to test it and fix those bugs. So I'll hit compile again. Okay, we have bugs. Let's bring our GUI back. That's too much. We'll go back a bit. Back a little more. There we go. Okay, so line 34 is here. Unknown function get value, so we're calling get value here, and we're also calling it here. So btn solo index get value saying unknown, or btn mute index dot get value. So did I misname one of our arrays? No. Btn solo, btn mute. That all looks okay. If there's anything obvious here, I assume you've spotted it already. Btn solo index of component. We need component. That's probably why. Let's hit compile again. I'll move the gain knob. We get no errors. Click these buttons. We get no errors. Okay, so it was just that typo that was causing the issue there. So now let's check it actually works. So I've got my interface here on the front end. Again, if you don't have this, just click one of these plus buttons to add a new empty panel. Right click and select, I think it's script content. Yep. And then select your interface here. And then you've now got this on the front end as well. Another option, if you don't want to do it like that, is you can go to View, Add Floating Window. And again, do the same thing, right click and select script content and put your interface there, and you've got it in a separate floating window. And the final option, of course, is to open it here, but this covers over the effects modules, so that's not quite as handy in this particular instance. So we've got this on the left hand side, so when we move these gain knobs, it should move the gain knobs over here. Channel 1, channel 2, channel 3. Or 0, 1 and 2, same thing. So when I hit this mute button, it should turn this gain knob to minus 100. Which it does, and the same for the other channels. And now when I hit any of the solo buttons, it should leave the knob of whichever one I hit at its current value, but the other knob should be set to minus at 100. Oh, that's not working. And I know why that's not working, and this is an interesting little issue. It is in fact actually working, but let me show you what's happened here. If we go back to our interface, let's make that a bit bigger. So btn solo 0 has been positioned over here at the end. Solo 1 is over here, and solo 2 is here. So it's just that the buttons are in the wrong positions, so we just need to shuffle these around a bit. So that's 0, that's 1. So really simple sort of mistake, but can be quite confusing if you don't know what to look out for. So we'll just line those up again. Okay. So just deselect those. Okay, so these should work now. So I hit the first solo button and it should mute the other two. And the second one. And the third one. And because of the way we've done this, we don't need to store the gain knob's value in an array or anything like that. So I think in the previous mute and solo button that I released, we were storing the gain knob's value so that we could recall it later on when we either unmuted or unsoloed channels. In this version, we don't need to because we're not actually changing the gain knob on the interface when we click the solo button, for example, or the mute button. We always have the value to reference because it's just the value that the knob's already at. We're just restoring that value that's already there. So if I set this, for example, to minus 16.9 and then I mute it, it will go to minus 100, but then when I unmute it, it's just going to recall the value directly from the knob and we get the same value. And the same with soloing other channels. And of course we can have two channels soloed at the same time, so that works as well. And a channel can be both soloed and muted, and the solo button will take precedence. And this is how it works in most DAWs. And of course, as soon as you unsolo, then those channels become muted. So that's a really good way to sort of toggle muting and soloing. So as you can hopefully see, this is a very elegant solution that Lindon has come up with only one slightly complicated bit of logic in that solo mute process function. But you never need to worry about that again because I've given it to you here, or more correctly, Lindon has given it to you, given it to us, so we can just use this in our projects without having to think too hard about how it's doing its job. I hope you found this video at least partly educational and completely enjoyable. Please leave your feedback below the video on YouTube. Thank you to all my patrons for their continued support and feedback. My tier 3 supporters will of course be getting access to the project files for this video, and if you'd like to access them as well, the link to my Patreon page is in the video description. Thank you for watching, and I'll see you next time.